What you're looking at now are real-world pictures of parabolas. As you can see, it looks like an upside-down U. In all of the pictures here, you see the parabolic shape, even in the rainbow, the McDonald arches, the fountain. The information that we are going over today, those equations were used in building some of these parabolas. Even when you think about shooting a basketball, parabola. Dropping something from the sky, parabola. So once again, all of the equations that we're going to talk about, and this picture is a good example. All of the equations we're going to talk about today, or the parts of a parabola, went into building some of these. So let's get started. All right, so today we're talking about 7.6 characteristics of quadratic graphs. First things first, let's talk about the standard form of linear equations. Our standard form is ax plus by equals c. And of course, we're naming the a, the b, and the c. So here, when we look at each equation, we know that the a is going to be, our a is going to be 1. Here we have -4, it's b, and c is -3. A here is 3, b is 6, -6, and c is 5. On this one, you can see that a is 4, b is 20, and c is 5. And of course here, a is 1. There is no b because we don't see by. So therefore, that's 0. And our c is 5. All right, that was just a quick review. Here are some definitions that we are going to use today. Quadratic function, a function of a degree 2. The graph is called a parabola. That's what we were talking about. That's all of those shapes that you saw here. Again, you see the word right here, parabola, parabola. And again, though it looks like parabola, it's not. It is parabola. All right, so the graph is called a parabola. When it talks about a function of degree 2, that simply means what we've been looking at already. Remember, we had x squared. Well, that's a degree of 2. So when we had 4x squared minus 6x plus 1, this makes it a function of degree 2. All right, once again, the graph is called a parabola, and it is either going to open downward or you're going to see some that opens upward. Domain, the set of first numbers, and we know the first numbers is our x in our set of coordinates. So if we had 1, 4, then we know the domain would be the 1. Our range is the set of numbers of the ordered pair, and it's the second number. I need you to underline that on your paper. Make sure you underline the first number. And of course, that is going to be 1 and 4. But your range is going to be the 4 this time. It's the 4 where your domain was the 1. Extrema is the points that are locations of relatively high, very important, high or low functions. Actually, here, I need you to make a note that this is the curve. You're talking only about the curve. If the curve is up, then it's called high. If it's low, down is called low, but there's a new name for them. We're going to get to those names. All right, we have an axis of symmetry. It's a vertical line that cuts the parabola evenly down the middle. Zeros is where your graph intersects the x-axis, and I need you to underline roots, solutions, x-intercepts, and zeros. We didn't underline the rest because we'll get to that. But I need you to know that your zeros are also called roots. They are called solutions. They are called x-intercepts. You will see sentences in which they will ask you for the roots. That's the same as your zeros. They will ask you for the solutions. That's the same as your roots or x-intercepts or zeros. They'll ask you for your x-intercepts. Hey, those are solutions. Those are roots. Those are zeros. All right, here we have intervals of increase, intervals of decrease. And of course, that has to do where your graph is going up or it's going to go down. We'll get into all of these in behavior. It's the behavior of your graph, positive right, negative left. We'll get into all of this. All right, but it was important to read through them first. Okay, first thing we're going to do is we're going to talk about the domain and range. And while you're taking notes, please listen. If you just scroll through this and take the notes, you're going to miss a lot of important information. All right, here, so we said the domain is the value from left to right on your parabola. The x value, all right? And your parabola, very important. It is always, your domain for the parabolas is always going to be negative infinity, positive infinity, or you will also see the word all real numbers. What does that mean? That means if we ask you for the domain of this parabola, you're going to look up here and you're going to say, well, the domain is negative infinity, positive infinity. The domain is all real numbers. And the range, well, that has to do with your y. We'll get to that in a minute. Let's talk about domain. Guys, it's very important that you understand this. When we talk about domain, let me draw a Cartesian plane minus all the other things. So let's just get an x and a y. All right, we got that, and we got that. Okay, now, let's say you have your parabola. When we're talking about parabola and negative infinity, positive, then right here, I need you to put positive, let's see, make sure. I need you to put positive infinity. And that's on the x line. Over here on your x line, I need you to put negative infinity. Why? Because we're talking about all the way, from eternity to eternity. All right? And so those are infinities. And when we talk about domain and we have a graph, so it's simply saying, and let's use red, a little thicker. Let's say your graph, let's make a parabola. And let's make it wide. And let it hit there, wide. Okay, this is a parabola, but so is this. And this one is showing you how it goes. You see positive infinity and how it goes. You see negative infinity. That means this parabola, as long as it continues to grow and it goes forever, it's going to continue to go out, out, out. And on this side, it's going to do the same thing. It's going out, out, out on both sides, no matter what. And that's why it's called negative infinity, positive infinity. Why is it called all real numbers? Because it includes every number on your number line, from negative infinity all the way to positive infinity, from negative 1 zillion all the way to positive 1 zillion. All right? So when we look at this, once again, with this parabola, that means it's going to continue as it goes up. It's going to go out and out and out and out and out. And this way, it's going to go that way, over and over. So it's always going, it's not going to curve, but it's just going to open up like that, which means it's going from positive infinity to negative infinity. That's what that means. All right? And that's why we say the domain is always negative infinity, positive infinity. All right, so let's talk about the domain first, which is right here. All right, so here it says state the domain and range of the graphs. Right now on this one, we're going to focus here on the domain. All right, first of all, you need to know, and oh yeah, you need 2 or 3 colored pencils. So pause the video and get your colored pencils or your colored markers, either one. All right, so first of all, let's look. Let's get rid of this. Yeesh. All right, first of all, let's talk about your domain. Domain, that's the first question. And with your domain, that means it's asking you on the x, and this is the x that we're talking about. So if we put the x line up here, that means this is still going out. This is negative infinity that is going out to, and this would be positive infinity that it is going out to if we're looking at x. And that's what this is, domain. So your domain, again, is always from negative infinity to positive infinity. You would see it written in different ways. This is one way. This is or. This is another way. You see it this way and this way most. But you will always also see it here. All they're asking you is how far does it go? It goes from negative infinity to positive infinity. It includes every number in the world, all real numbers. All right? Except for the unreals or imaginaries. All righty? So anything that we can put on the number line is real. So that's domain. All right? So that's what they're talking about. From this all the way to there. Now, when we talk about range is going to be your y point. So your range always starts at the curve. I think we put something up here. Yeah. Second number here, we're talking about the curve, even though we said extrema. But your range is always that point on the curve. So if your curve is on the bottom, so here I need you to put range starts. And it only starts here if your parabola opens up. So range start. Again, this is when the parabola opens up. And this is your range end. This is the end of the range. And the question is, where is it going? Guess what? We're going to put positive infinity. At the bottom, we're going to put negative infinity. Now, where is our range going? So it starts here and it is going all the way to positive infinity. So whenever your parabola opens up, when the range, it opens up, it is positive infinity. Positive infinity, whenever it opens up, it is positive infinity. All right? And that means this one, the range started at 1. 1. And the range, remember, that's your y. It started at 1. Positive infinity started at 1. So the range starts at 1, and it goes all the way to positive infinity because it opens upwards. So here, this is how we write it. It started at 1, so we wrote 1. And note, we put a bracket here whenever we're talking about range and a number with infinity, but parentheses when we put the infinity. So it went from 1 to infinity. And yes, you will see it written like this too. All right, put both of those. All right, let's go to the next one. On this one here, what is your domain? Remember, domain is always. Domain for parabolas is always this. Now, this answer only works in Math 1, Math 2 that you're going to deal with. When you get into Math 3, things are changed. Your parabolas are flipped and go sideways. Or Math 4. So here, we know our domain is going to be right here, negative infinity, positive infinity. And again, that's two ways to write it. And what else can we add? Yes, all real numbers. That looks bad, doesn't it? Now just put a dot. All real numbers. So either one of these you will see to describe the domain. Now, what is your range? It's opening on the bottom this time. And let's look at where your range starts. Your range is always there dealing with the curve, except this time, the curve is where your range ends. Why is that? Because that's as high as it can go. Your range starts down here, and remember, that is negative infinity. And it goes all the way and stops right there, and then starts going down again. So your range starts here at negative infinity. Now, don't pay attention to where that arrow is. That arrow means it goes forever and ever and ever. All right? So when we write our range this time, we're going to put that it is negative infinity, and it goes up and stops at, it looks like it stops here at positive 4. So that means our answer is going to look like negative infinity, comma, 4. And note your brackets for the 4. All right, so it starts at negative infinity, ends at 4. And that's when it opens down, when it opens downward. All righty? Or when your curve is on the top. And we always put the smallest number first. Smallest first. Smallest first. All right, now let's go down to, please take time to look this over. If I'm going too fast, we'll slow it down. Now let's look at extrema, axis of symmetry, and zeros. Now here for extrema, it says it's all about the curve. I need you to put that in your notes. All about the curve. All about the curve. Your extrema is called vertex. I need you to underline vertex or circle it. And when you're dealing with the vertex, you're dealing with coordinates. We'll get into that in a minute. Now, your extrema, when we talk about it, the terms you're going to use will be minimum. If your parabola opens at the bottom, it's minimum. If your parabola opens at the top, well, that's called maximum. Your axis of symmetry is always written as x equals a number. Then we have zeros. It's where your graph crosses your x-axis and is coordinate points. We'll get into this so you'll understand what it means. All right, but again, this extrema, I need you to remember that your extrema is also called the vertex. When you write extrema, you put minimum or maximum. But when you write the vertex, you must use coordinates. Let's see what we're talking about. And again, remember that old extrema is about the curve. All right, so let's look at this parabola here, where we're only dealing with those things. Now, right here we have, it says state the extrema, axis of symmetry, and zero of the following graphs. So I need you to put a dot here at the top. That's the absolute top of your parabola. That's as high as it can go. That's its extrema. And because the extrema, the curve is on the top, it's called maximum. That's as high as it'll go. But I also need you to put the line, and I need you to write vertex. And next to vertex, I need you to put the coordinates. Where did we get to 16? To 16. That tells us exactly what that point is. Vertex, extrema, same thing, except extrema use maximum or minimum, Vertex uses your coordinates. So circle, highlight that. Now I need you, using a different color, I need you to circle your zeros. Remember, another word for zeros is root, solution, or just what you see, x-intercepts. X-intercepts. That's another name for solutions, another name for zeros. All right? All of those are the same things. So I need you to circle them. Sometimes you will have 1, sometimes you will have 2, and sometimes you will have no x-intercepts. So circle your zeros. Now, using a different color, let's draw a line straight through that point. And that line, that vertical line, is called your axis of symmetry. Axis of symmetry. And here we use the term AOS. And where we said it's written as x equals value 0, that means we write it as x equals whatever that number is. That's how you write your axis of symmetry. All right, written as x equals, that's the one I'm pointing to. X equals, that's the green. And that means it's written as x equals 2. Why? Because it's the x value. It's the x value. It's the x value. So here, if you didn't underline that it is the x value of the extrema. Remember, another word for extrema is the vertex. Our vertex is 216. Axis of symmetry is 2, the x value of that. So here, our extrema is maximum. And here we put is maximum at 216. And I need you to draw a line and write the word vertex. I need you familiar with that. Axis of symmetry, you must put x equals 2. And your zeros, it's where it's crossing the line, where it's crossing. And it's crossing the line right here at -20, right there, and at 60. And you must write the whole thing. It's where it's crossing the line. All right? Okay, remember your extrema, axis of symmetry, and your zeros where it's crossing. Extrema is wherever that curve is. And your axis of symmetry is where it's splitting your parabola in the center vertically. Now, let's look at this other one. Now, looking at this other one, of course, we can see that old extrema is at the bottom this time. So the curve is low, so it's called a minimum. That's as low as it can go. You know, how low can you go? All righty, so that's what this one is, this extrema. And I need you to draw that line and note that this is your vertex. It's your vertex. Let's see if we can make that word vertex look a little better than it looks. Your vertex, and that number is -1, 3. Where do we get 1, 3 from? Right here. It's -1, 3. That's your vertex. But the extrema, you use minimum or maximum. Axis of symmetry, remember, it goes right through that old vertex, cutting it in half. Cutting it in half. How do you know it? Split it in half? Because look, you can go from this line over 1, 2, and go from this line again over 1, 2. Split it in half. Axis of symmetry. And remember, how do we write that axis of symmetry? Yes, we put x equals, and you don't have to put it here. You have a line at the bottom. X equals what? And remember, it's always, even if you don't look at this and you've already written down your vertex, you know it's going to be the first number of your vertex. You know it's going to be -1. -1. Yep. But again, you don't have to write it there. Why? Because you can write it right down here. We have a minimum at -1, 3. Again, I need you to draw that line, and I need you to write that word vertex. We said our axis of symmetry, and you must put x equals. And our zeros say what? It does not intersect x-axis, so no real zeros. What? Exactly. If it does not touch your x-axis, if it does not touch your x, no zeros. No zeros. All right? Awesome, awesome, awesome. Now, let me, all right, so let's continue on and note each one of these sections have been divided to deal only with just that little bit. So we don't give you too much at one time. Well, now we're going to look at your intervals of increase and intervals of decrease. And I need you to write all about x. That's it. It is all about the x. The y is not involved, even though it's going to look like it. Both of these guys are only about x. Only about x. Has nothing whatsoever to do with the y. But it's going to look like it does, but it doesn't. Now, your intervals of increase, and it says where your graph, your y values increase from left to right, where the graph's y values decrease from left to right. But again, we're not even looking at y, right? I know it can be kind of confusing. Okay, so let's look at this. Let's see what I'm talking about, because this old thingy, it can kind of throw you off. Now, the first thing that's important, though, is I need you to underline from left to right for both of them, from left to right, because that's how we read. So we're going to read this from left to right. What do we mean? That means this is left, this is our left side, and this is the right side. So when we look at it, we always read from here and then we go. Or we read from here and continue to read it. All right, now this negative infinity, that's this one that goes for x. That goes for x. And it's like the one that we drew at the top, way up here. All right? It's that one. All right, so here, we just put it up here. And right here, got the positive infinity, but we're talking about x, okay? Talking about the x. Now, let's look at this. It says, what are your intervals of increase and what are your intervals of decrease? Now, first of all, we go to where the arrows are. And where does it start? Negative infinity. This is your grade. No, we don't want this to be your grade. All righty, so let's say it's the waterfall. And the waterfall is starting up here, yes? Yes. And the waterfall falls, and it stopped falling right here. All right, so that means it fell. That means it's decreasing. It's decreasing. It's going down. It's decreasing. It's decreasing. It's going down. And that's and look at your y values. Even though I said it all has to do with x, and I'll explain. You see how your y is 7, 6, 5, 4, 3, 2, 1. Okay, but we're not even looking at y. Let's go here. And I'm using that because I was using this definition. So you could just see that example. Okay, now where did it stop going down? It stopped going down right here. And where is that? Right on the 1. Yep, right on the 1. It stopped going down. So it goes down, that waterfall goes down until it hit 1. Then it stops. So what is your interval of decrease? Don't get them mixed up. Your interval of decrease is It starts at negative infinity, right here, and it falls all the way down, and it stops at 1, right there. So your intervals of increase, you're going to see it written like this, meaning negative infinity is less than x, because this is the x, but it stops at 1. You're going to see it written in this way also. All right, this way probably more. So be familiar with both of them. And this time, since even though you have a 1 and an infinity, you use parentheses because it's a point. Now, what happens? Once that water hit that pond 1, once it hit that pond 1, then there was a hose or some large vacuum that started pulling it up. And it's going up and up and up and up and up. And because it's going up, then that is called your increase, because it's going up now. And it's going up to what? It's going up to, yeah, that's supposed to be an E, up to positive infinity. All right, so the question is, where did it start? It started at 1. So since it started at 1 going up, we put 1. We're dealing with the x value. And where is it going to stop? It's going to stop at positive infinity, which means it's never going to stop. All right, so that's how you read that. And again, you're going to see these both ways. You're going to see it written like this. It started at negative infinity and went all the way to 1 for the decrease. And for the increase, this one, increase, it started at 1 and went up to positive infinity. All right, and again, 2 ways to write them, this way or this way. You're going to see both of these ways. All right, let's look at that other one. Okay, hey, it's flipped, huh? So this one is flipped. So I know, pause your writing, but let's look at it. Now, remember, we read from right to left. I'm sorry, I was wrong. We read from left to right. Remember, when you're reading, we read this way. Da, 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 da. Okay, so hey, guess what? Something changed. Since we read from this way, that means we started here at negative infinity, and we're going up, 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 up. And where do we stop? At 3. So guess what? This is increase. Yep, that's your grade. It's increasing. It's going up and up and up. Every time you think about it, it's going up and up and up. That's your increase this time. Why? Because this is how we read it. So just because it's on the left doesn't mean it's a decrease. Remember, we read based upon where that line is going. So it started at negative infinity, and it stopped at positive 3. Increase. So it started at negative infinity. We're dealing with x, and it stopped at 3. Now, then what happened? After it got to 3, then all of a sudden, your parents rewarded you with taking you to see the waterfalls, Niagara waterfall. Whoa. Or just all the different waterfalls. And when you got there, you saw the water, and the water was pouring down, 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 down. So this is a decrease. And our decrease starts at 3. Starts at 3. We're dealing with x, and it ends at positive infinity. And I know you're saying, what? How can it decrease to positive infinity? hey, that's the way the line is going. You know, we don't ask questions about why we can breathe air, yet we don't see it. So, hey, that's just the way it goes, because that's the way the line is going. All right. So don't question whether it's positive or negative and how can that be. Just simply pay attention to what's happening with the line. And this line is going towards positive infinity, but it's decreasing. So we can just say we have a waterfall that is going towards a large, large lake that is called positive infinity lake. All right. Awesome, awesome, awesome. Okay, if you need to look back at this piece, look at it. And once again, you'll see it written like this, or you may see it written like this. Either way. All right, now let's move on to the last part. And our last part is talking about end behavior. Oh my goodness, this one is like, ay, ay, ay. Okay, the description of the y value in behavior is the description of your y value as x becomes large in the positive and negative direction. Now, guys, this is how you read it. Please pay attention to the notes. Don't just copy it. It's called notation is x. This arrow means approaches. I'm going to draw my line. And I'm going to type it because my writing is messy when I try to write on this. All right, so it's approaches. It approaches. That is what that word that is. That arrow means approaches. So x approaches negative infinity. Y approaches what? It's either going to be positive infinity if it's going up, or it's going to be negative infinity if it's going down. And then here you're going to see it twice. You're going to see it again. You're going to see a positive and a negative as x approaches. Positive, and then y approaches. Again, it means approaches. Means approaches what? Means, okay, so let's look at it. It says mean what y is doing on the right side of the graph. And it's positive if it's up, negative if it's down. Okay, let's see what that means. All right, so as we come right here, all that this thing is asking you is, what that means is this. This is your parabola, right? Notice it's going down. Every time it goes down, remember, we said that when your parabola is pointing down, then your range is going to be negative infinity. And you might ask, what does that have to do with anything? I'm going to explain it to you. Whenever it's pointing down, it's always pointing down at negative infinity on both sides. This is going towards negative infinity, and this is going towards negative infinity. Both of them going towards negative infinity. All right, so what that means is this. So let me explain. It says in behavior, as x approaches negative infinity. So that means, and let's use another parabola, but it represents the same thing. So let's use this parabola, and let's say your parabola is going this way. You see it's going towards x, yes? And you see it's going towards negative infinity. My question to you is, which way is it going on y? You see it's doing two things at the same time. It's playing towards x, going that way, but it's also playing towards y, going that way. Okay, you see it's going down, And because it's going down, it is going down towards negative infinity. Okay, so it's going down towards negative infinity for y. Okay, so both of those are going to be the same. Now let's look at the positive side. On the positive side, it says that, oh, x, and here it is again, it is going towards what? Towards what? It's going towards positive infinity. But as it goes towards positive infinity for x, which way is it going for y? And somebody said positive infinity. Is it going up? No, it's not going up. That's positive infinity for y. No, it is still going down. Still going down. So that means that is negative infinity. So it doesn't matter which way x goes. It doesn't matter. X can go negative, x can go positive. Your y is always going to go the same way that it goes on both sides. So on that one, as x approaches negative infinity, y approaches negative infinity because it's going down. As x approaches positive infinity, y approaches negative infinity because it's going down. In other words, if it's going down, just like here, that means you got a frowning face, and both of these guys are negative. They're sad. We're going down. My arrows are going down. Sad face, negative infinity. You will never have to fill in your x. You will only have to fill in your y, and your y should be the same every time. Negative infinity, or, and that's when it's a frowny face going down, or if by chance it's going up, well, things change. You know, we get a little bit excited. So on this one, and we're looking again for that end behavior, looking for end behavior. So let's look at it. So here it says as x approaches, and that's on our left side over here. So again, let's draw a different parabola. So as your parabola is going this way towards what? Yup, negative infinity. What is your y doing? Whoa, y says, hey, dude, hey, dude, hey, dude. Y is going up towards its positive infinity. So where x is negative, y is positive. You see, x doesn't affect y. In this case, y says, I'm going to be happy. I don't care what. And that's on the negative side. But hey, what happens on the positive side? So as x, again, x is going towards positive infinity. Because this is positive infinity over here. What's y doing? Same thing. It's still going up. Sure is. Still going up. So when x approaches positive, guess what? As long as it's smiling, yay! Woo-hoo! Y is always positive. Y approaches positive. So we got a positive infinity here and a positive infinity here. That's our end behavior for our Y. So down here, that says, see, happy thoughts. As x approaches negative infinity, y still went up to positive. As x approaches positive infinity, y approaches positive infinity. You see, I need you to notice once again, both of these answers are going to be the same. Both of these are going to be the same. Both are the same. Both are the same. Same. Both are the same. Not the same as x, but the same as each other. Happy face. All right, let's look at this one. Over here, it says, again, let's play with x. X is going to this way. And what is that? Negative infinity. Let's get rid of this so it don't confuse us. So x is going towards negative infinity. And what's your y doing? is going down. Y is going down. Y is going down. And as X on the right side, oh, wait. So since Y is going down, that means Y is going to negative infinity. And on the other side, as X is going towards positive infinity, this is positive infinity, then what's your Y going? Your Y is going down. It's going down towards negative infinity. Once again, both of these are the same. Your Y's will always be the same on end behavior. Let's check it out and see. X approaches negative infinity, Y approaches negative infinity. How do we know? Because we got a frown. And whenever we got a frown, Y is negative. As X approaches positive infinity, Y is still going to negative because we got a frown. And remember, both of these are always going to be the same. All right, so that is the completion of this assignment. Now, what you're going to do is you are going to go to the other assignment. All right, now, so from this, you're going to work on the worksheet that you have. Your teacher will hand it out if that has not already been handed out to you. So your worksheet title is, yes, Characteristics of Quadratic Graphs. Let's work a little bit together. Let's see. So you have a parabola. Now I would encourage you to label as much of it as you can. Oh, yeah. So you can label as much of it as you can. You know what this is. You're looking at these. So we can come here and just label. We know this is our vertex, another word for extrema. And I put vertex on your sheet. We have zeros. We can see them. We can circle them and label. There are zeros. And you need to know those numbers. And remember, we read from the left to the right. That's going up. This is going down. And use your colored pencils. Use your colored pencils. All right, so let's go through this first one. We can do this together if you want. Or you can pause the video, label it, fill these in by yourself, and then check your answers. Okay, let's check. Your domain, remember what the domain is. Negative infinity, positive. There we go. Range, remember where it starts. In this case, it ends because it's upside down. So it's negative infinity to what it stops at? 1. Now see how your graph is jumping, okay? Axis of symmetry, it's your line going down, and it is going to be the x value of your vertex. It is x equals -4. Your extrema is at the top or the bottom. It's at the top, so it's a maximum. And this is your vertex, vertex. Okay, that's your vertex. Zeros is where it's crossing. -5, 0, -3, 0. And the 0 is always last. It's going up from the left side. Remember, up from the left side. So it's increasing from, what's this number here? It looks like a -3, but no, that's called negative infinity. Remember, don't worry about that arrow. Negative infinity. Right? Negative infinity to -4. Don't worry about that arrow. Negative infinity. And it stops right here at -4. -4. And then from there, it goes down. It goes up and stops at -4. Then the waterfall starts. And the waterfall is decreasing from -4 all the way to infinity. Yes, practice writing both ways, because you never know which one you're going to see. In behavior, it's opening downward. So what's your in behavior going to be? Remember, these guys are the same. Positive, negative infinity indeed. All right, so I need you to complete the rest of the sheet and turn it in. I hope you guys have a great day and a fantastic weekend. Take a picture and upload. Actually, don't turn it in. Take a picture and upload it. Take it home and study.